Priyansi. Welcome back. Today we're going to be touching a major milestone. We're going to be introducing the idea of loops. At least half the idea, because as you can see from the title, it's part one. So let's start. What is this loop thingy? What did you just mention? Well, right now, if let me give you an example. If I told you that I wanted to print hello 5 times. Right now, from what we have learned, all you can type is print the print statement 5 times. So you would repeat printf and then you would copy paste this 5 times. But what if I told you I don't want this to be 5 times, I want this to be 10,000 times or a billion times? Would you keep on copy pasting it? Well, no, right? There has to be some sort of mechanism because the basic idea is what I want you to repeat 10,000 times is just this small print statement. Okay, so if there was some way in which we can, there was some structure in which we can repeat this block of code 10,000 times, well, that would be pretty damn cool, right? So this is exactly what a loop does, is that it repeats a block of code until a specified condition is met. Our block of code here would refer to printing the print statement with hello world, and the condition is less than 10,000 times or a billion times for that. So, a kind of an interesting trivia is that Ada Lovelace, the genius mathematician, was the first one to use a software loop, and she used this to print out Bernoulli numbers. Now, we don't want to get into what Bernoulli numbers are, but just know this interesting fact. Also, there are three kinds of loops that we will see later. For loop, while loop, and do while loop. But before we get into that, I want to quickly discuss an important concept, that is the go-to statement. So the go-to statement, it's not technically a loop as you can see from the title, it's a jump statement. Now what I mean by the jump statement is that, let me show you something, is if you remember our operators program. So what was the flow of the program? We started with main and we just executed line after line till we reached return 0, right? This was the flow of the program, top to down. And if with conditional statements, we learned that we can jump actually certain parts of the program based on some conditions. Okay, but it has conditions to be required, right? We cannot just jump without any condition. So what a go to statement does is that it can also jump to some other part of the program. For example, if this was here, it can jump right towards the end, but it doesn't need a condition for that. These are unconditional and it can go both ways. If in this part of the program, go to can take you this part of the program. Now if you can do this, you can, if you just think back for a second and realize how powerful this concept is. You're jumping all over the countryside, you can literally go anywhere. And for this exact same reason is for the reason that goto can do almost anything, is the reason we don't use goto. For this leads to something called spaghetti code. What is spaghetti code? Well, it's a mixture of, you really don't know where your program is going, because just think, if there were multiple go to statements, you cannot really figure out the flow of the program. And I'm going to prove that to you why we should avoid using go to. So let's take our initial example of printing hello world some number of times. Okay, so this program will print hello world just one time. Sorry, hello world. This program will print hello world just one time, but we want to do this again, so we will write go to and then we'll give this a label because we want to go to a specific part of the program and there will be multiple go-tos. So what will differentiate uh, is this label. This label will be different for different go-tos, and we just said that here. Uh, it it allows us to transfer control of the program to a specified label. So our label here is again, and what we want to do is go to again the top of the program so that we can print hello world. But if I do this, and if you are trying this out side by side, I recommend you try this out in the terminal and not just use code runner for this because something is about to happen that we're not gonna like. Spoiler alert, by the way. So what is happening? There are a lot of hello worlds. Why isn't this stopping? Let me just quickly press Control C to to come out of this infinite loop, I would say, that we have created. It's just repeating itself again and again. So what happened was we had no way to come out of this go to hell, I would say. Okay, so let's do that. What do we need to come out? We need a condition to come out. Okay, so what will be this condition? Suppose we want to print hello world just 10 times. So our condition is that once we have printed hello world 10 times, we have to come out of this go to block. So let's define a counter. A counter is exactly what it sounds like. Let's initialize this to 1. So it counts the number of times hello world is printed. And let us introduce the condition inside this, between this go to block, and write if counter is greater than 10. We want to come out of this go to block. So sorry, gonna come out of this go to block. So what will we do is we will introduce another go to for that. So let's name this exit go to, and we want to come out of this entirely, so we'll just go towards the end of the program so that the program can be terminated. And remember, a go to label is mentioned with the help of a colon at the end. So this is just the name of the label, that is why it is terminating with a semicolon, and this is the label where you want to go. So colon. So we should be able to come out of the program, right? Let's try and run this again. No, wow, this just won't stop, right? Where did we go wrong? Well, a counter is set to 1. We are checking that whether it has been, it goes greater, it it updates to greater than 10 or not, but we are not really increasing our counter, so our counter remains 1. So no matter how many times this hello world is printed, the counter won't be able to track. So we need to update our counter somewhere within the program. So let's do this after we are printing out hello world. So let's do a quick plus plus of counter. So if we have done this right, I think we should be able to get what we were hoping for. And voila, we got it. 10 times hello world. But you notice what happened to a program, right? You cannot really figure out the flow of the program. First, you're encountering this label when you're going down, then there's another go to, but there's this, but it has a different label from what you have encountered. Then there's again, and you're noticing that we can go either way, either it's from top to down or it's from bottom to up. So there has to be a better way to do this, right? Go to isn't shouldn't be the answer actually. Turns out there's actually a better way of doing this, but before we jump into that, pun intended, let's discuss about where we can actually use go to, because go to statements aren't the problem. Undisciplined go to statements are, because it is so easy to write bad code using this. Go to statements are useful in jumping out of nested loops, but we still avoid it because if as amateurs, if we cannot adopt the best practices, let's not adopt the worst ones too. Okay, so moving on to for loops. So at the beginning of this video, we discussed about the three kinds of loops, right? For, while, and do while. Now, this is an analogy that I would like to make, and I love this analogy because consider these three kinds of loops as the Hemsworth brothers. There's the for loop, or Chris Hemsworth, or Thor, as you all know, who is known by everyone. We use it almost all the time, and it's really famous. Then there comes the while loop, which is Liam Hemsworth, and he's also used in certain specific cases, not as popular as Thor, but definitely popular and really useful in some specific use cases. And then there's Lucas Hemsworth, who like, or the do while loop, who we know he exists, but let's not get ahead of ourselves, right? Like there's like one, like 100 out of one possibility, like 1 out of 100 possibility where we will use do while loop, but they are, nevertheless, they are important too. Okay, so let's start with discussing Chris Hemsworth of loops or for loop. So a for loop goes, as you can see in the flow chart right here. A for loop has three parts. You got the initialization, then you got a condition, a test expression that you have to check, and then you got updation. Now let's see this. How will this work? So we had our we had a program with go to, right? So you can see, you can actually notice the parts here of that are applied in a for loop. You got initialization, you got, see, you can see the condition is right here, and then you have the updation. Okay, so let's try to recreate this using for loop. So the syntax goes like this: for, and then this parentheses, and then you have a counter which is initialized. Let's initialize this as 1. Then you have a condition which is counter is less than 10, less than equal to 10, because we want it to be 10 times. And then you have the updation. So what actually is happening, I'll expand this. So what actually is happening, counter is equal to counter plus 1. So this is where your counter is getting updated, and then within curly braces there's your loop body. And there's one more term I would like to know. The counter here is also called a loop variable or a loop counter. Yeah, and what we want is printing hello world. So I think we have checked all the marks here, I guess, that were given in this flow chart. So we have the initialization, we have the expression, we have the body, and then we have the update expression. So let's first see the output, and then we'll go over this step by step. So the output remains the same, as you can see, because we have just recreated what we wrote in GoTo, right? So let's go over this step by step. So let's start from the top. So first we have initialization, and what you need to remember is that the entire time a for loop runs, this initialization statement is executed only once. So once we are done with that at the beginning of the for loop, we move on to check condition. And a condition is 1 less than or equal to 10. Well, yes, this is evaluated as true, and then we are granted entry inside the loop. And for this reason, there's a keyword that you need to remember is that for loop is an entry control loop. So if this condition is not satisfied at first, we won't even enter this loop. This condition, if this condition returns false, we will just jump to here. We won't ever see this loop body. But since this did not happen right now, we are granted entry inside the loop. So, and then we'll go over the entire loop body. So right now our loop body prints out hello world. So we'll just quickly print this out. So once we are done that, and we reach the end of the for block, we will move on to updation. So as you remember using the go to statement. When we did not update, we got an infinite loop. So we do need to update it so that the counter can keep track how many times hello world has been executed or the loop body has been executed. So once we update that, so right now our counter becomes 1 plus 2, 1 plus 1 is equal to 2. We go on to check the condition again. So is 2 less than equal to 10? Well, yes. Again, it's evaluated as true, and after we check the condition, we go to the loop body right here. And again, we print hello world, and this keeps on happening until we reach, until let's say our counter reaches 10. So when our counter reaches 10, it still satisfies this condition, counter is less than equal to 10, and it again prints out hello world. And remember, in between these there are 8 more hello worlds till from 1 to 9. Okay, so it reaches, it prints out hello world because 10 is less than equal to 10 and it's true. But then when we reach the end of the body and we go to the updation, now our counter is equal to 11. Is 11, shift this over here. Now, is 11 less than equal to 10? Well, no, this is evaluated as false and we come out of this loop body altogether. So in our loop program, if we print out the value of our counter now, this should be 11. Yes, you can see that we are getting 11 at the last. So that was a basic for loop. Let's see what more interesting programs we can do with this. Also, why do we use for loop is that when we know the number of times the loop will be executed. Okay, so here the number of times that the loop will be executed, well, it really depends. It can be 10, it just depends upon the condition. So you know that till this condition is satisfied, the number of times this loop will be executed, because you need a proper updation of the counter. So instead of counter is equal to counter plus 1, we can write plus plus of counter and we will still get the same result. Let me just move this. We'll still get the same result, hello world. What if I do something like this? Counter is equal to counter into 2. So let me just also print the counter alongside this. And counter. Okay. Let's see what our output will be. So is we can not only update the counter by 1 or 2. It's just not addition. We can perform any sort of operation here, division, multiplication, etc. So what happened, our counter was 1 and then 1 into 2 became 2, then 2 into 2 became 4, and 4 into 4, 4 into 2 became 8, and then 8 into 2 became 16. And if we print out the value of the counter, which was 16 when it was kicked out of the loop, I think we'll get 16 as the answer. And yes, we did. So let's check out some more interesting things that we can do with this. Um, let's print out all the odd numbers within a given range. So how will we go about that? So a counter is still there. Let's define a range. In start is equal to, let's say, 10, and end is equal to 20, and then a counter will just loop over from start to end, so from 10 to 20. So the initial value of our counter should be equal to start, right? And once we have initialized the value of the counter somewhere, we really don't need initialization. So instead of counter is equal to something or start again, we can just write counter, and the for loop will consider the initial value of counter as the initialized value of the loop variable. Then we have to check if counter is less than or equal to end, right? So once we've done that, all we need is counter plus plus of counter. And how do we check if we have an odd number of nodes? So if you remember from operators, we saw a cool trick is that we can check by simply doing counter and 1. So a bitwise operation, and if this is true, then this is an odd number. So let's just print this out. And we're printing out counter only. Let's check out the output. And yes, these are all the odd numbers between 10 and 20. Like this, you can do all kinds of cool stuff. And let's also try something out. If there is no condition, so what we can do is we can exclude this statement. So we know that the for loop should have three parts. So these three parts you can actually omit these three parts if you have some sort of mechanism for checking. So if I put so I just omit the condition statement, but I introduce something here, like if counter is less than equal to is less than equal to end. So actually a condition should be if it becomes the counter becomes greater than end, then we'll have to come out of this program. And remember what we used to come out of a block? If you guessed break, then you're absolutely right, because we used to come out use that to come out of the switch block. So just like the switch block, we can also come out of this for loop block by using break. Let's see what answer do we get. Yes, we get the exact same answer. So you can experiment around with this. You can omit statements, but it has to have three parts, okay? And let's see if we can skip initialization too. Let's see if that will work or not. That actually worked. So you can experiment around with this, and you'll get really interesting answers. So let's write a useful program now. So what can we write? We can actually write a program to find out the factorial of a number. So what is the factorial of a number? Well, the factorial, if you have 6 as a number, then the factorial of the number is 1 into 2 into 3 into 4 into 5 into 6. So if you think about the underlying extraction, these are just the counters, and every time you are multiplying the counter. So this is actually your updation, and this is the counter. So let's see if we can write write the code for it. So let me just fix the counter to 1, and we have a number to start with. Let's choose the number to be 6, and then we'll have another variable called factorial, where we will store the factorial. So we are starting out with 1, because for reasons that I will show you after I write the code, I will explain this to you. So just counter is less than equal to num plus plus of counter. So what is happening is that, let me also write the condition, which will be factorial into, let me just write the entire thing, factorial into counter. And if we print it out, we will get the right answer. Let's just print it out to factorial. We should get 120, sorry, 720, 120. Okay, I'm forgetting my maths. 720. So that happened. Let's see. Let's see the underlying logic. So you have, let me just quickly copy paste this here. So you have a counter, right, where our counter is equal to 1. So we start and our factorial is equal to 1. So in the first loop, what happens is first we, the whole drill, right? Checking if it's less than equal to num. So what's happening here is that you are updating factorial. And what is factorial? Factorial is equal to factorial into counter. So for the first iteration, our factorial value will be 1 into counter, which is equal to 1. So right now the value of factorial is equal to 1. When counter is equal to 2, you are then updating factorial by saying factorial is equal to, right now the current value of factorial 1 into 2, which is the value of the counter. So f is now equal to 2. And if you continue like this, you will actually get the value of the factorial. 2 into 3, then 6 into 4. So these are all your counters and these are the current value of factorials. So I hope you understand why I chose factorial is equal to 1, because we are actually the operation that we're using here is a multiplication, and if I chose this to be 0, then all of this would be turn out to be 0 in the end, which we don't want. And what exactly is going on here? Let me just clear that 0 out. Yes. So what exactly is going on here? Remember at the beginning of this problem, I wrote something out, like what the factorial of 6 will look like. 1 into 2 into 3 into 4 into 5 into 6. So what's happening is that we are storing the previous answers, calculator answer. So this can be interpreted as 1 into 1, and then we are multiplying the new counter with this previous answer. So we are storing 1 into 1, and then when our counter is updated, we store is in this into factorial, and then again our counter is updated, we again store this entire part into the factorial, so that we can now multiply it with the counter. So if you understood this underlying abstraction, think about how beautiful this concept is, just storing and multiplying, and it's so easy to find out the factorial with this. So ponder over this program. This is a really important program, but for now we will move on to break and continue statement. Okay, so we've already discussed the break statement in our previous video and in this video too, but I'll give you an example for the break statement before we move on to the continue statement. But first, I want you to remember this keyword. Break and continue are both conditional jump statements. So they are jump statements just like go to transfer the control of the program from one place to another, but they both operate on a condition. So until and unless those conditions are satisfied, they won't jump. Okay. So for break, we already discussed this program over here where we omitted the condition in our for loop, and then we just put this condition inside the program. So in case a counter exceeds the end value, we just jump out of the loop. So as soon as the break statement is encountered, we will reach here. We will automatically come out of this entire for loop. So moving on to continue statements. So when a continue statement is encountered, it skips the current iteration, which means that yeah, it skips the current iteration, whatever the counter value was, and it skips the rest of the body, the the loop body below that, and it just moves on to the next iteration. So I'll just show you this in code. Let me just copy the code for break statement, and then we'll build on from there. So what do we need? We need a condition first for the so for statement, because our loop cannot end if we don't have a condition. So less than equal to end, and let me just remove this. Now if you remember the condition for identifying if a variable is odd or not, or for number is odd or not, so this in case the number is odd, this evaluates to 1 or true. So in case of even, this will evaluate to 0, right? So if we check, if we have a condition like this, if this is equal to 0, let me just put brackets here for clarity. So if this is equal to 0, which means that the number is even, so we don't really need to print it. So what we will do is we will move this print statement outside the loop, and we'll just put in a little continue here. And if we check our output now, it should be 135. Let me just put it on different lines. So what happened was, when this was 1, it did not satisfy this condition, and we just printed out 1. But when this was updated to 2, this condition, this this was evaluated to 0, and this entire condition was satisfied. We encountered continue, and whatever was below this in the loop body, this was skipped, and we just moved on to the next iteration. Means we updated our counter to 3, and the process continued till the counter was less than equal to 10. So that's all for the looping part 1 video. We have some problems in HackerRank. You be sure to check them out. And if you're facing any troubles, there's always the HackerRank discussion forum. There's the Telegram group. You can reach out to us on Twitter, etc., etc. Just keep practicing, and thank you.